Hello, everybody. So today we're going to continue with our discussion of sixth grade Go Math middle school skills. We're on Module 13, Lesson 13.1. And we're going to be talking about Area of Quadrilaterals today. And so basically our essential question that you should be able to explain when we're done today is, how can you find the area of parallelograms, rhombuses, and trapezoids? Okay, so let's go ahead and get started. So activity 1, area of a parallelogram. So recall that a rectangle is a special type of parallelogram, right? So on grid paper, draw a large parallelogram, okay? Something like this, okay? And then we're going to cut our parallelogram along the dashed segment as shown, where it's representing the height of the parallelogram. So cut along that line. Basically, we're cutting off a right triangle. Okay. And if we move that cut piece, you notice that we form a rectangle, right? So with that in mind, okay, so again, all we did was cut along the dashed line for the height and switched it to the opposite side. And that formed a rectangle. Okay, so what figure have you formed? Does this figure have the same area as the parallelogram? Okay, well, that's what we started with, right? Did we change anything as far as the size? No, it's the same area, right? All we did was take the part that was here and moved it over to the right-hand side. So yes, it has the same area. So we can say the base of the parallelogram is similar to the length of rectangles. And the height of the parallelogram is similar to the width of a rectangle. And the area of a parallelogram is equal to the area of a rectangle. So that brings us to a general formula that we can use. So if we want to find the area of a parallelogram, like we started with, okay, if we want to find the area of that, we can say base times height, or we can say length times width. They're basically the same thing, okay? So what is the formula for the area of a parallelogram? Well, we say area equals A times base times height. Okay. Right, so again here, the area A of a parallelogram is the product of its base and its height. Okay, so if you know the base of the parallelogram and you know the height, we can find the area. All right, so let's do some practicing. So find the area of number 1. Find the area of the parallelogram. So start by writing the formula. And again, we said area equals base times height. Do we know the base? Yes. 14 centimeters is the base. So 14 times the height. Well, this part's the height, right? So 7. 14 times 7. 7 times 4 is 28 ones. Regroup that as 2 tens and 8 ones. 7 times 1 is 7, plus 2 more tens is 9 tens, or 98 square centimeters. Okay, remember the units is important in area. Area is something that's squared Okay, we're counting the number of square units that fill the space. So in this case, 98 square centimeters. All right, how about the area of a trapezoid? Now, so in this, you notice that two copies of the same trapezoid fit together to form a parallelogram. Okay, so we have this trapezoid, right? And if we make an exact copy of it and then flip it, we have exactly the same shape as a parallelogram. So in this case, the height of the parallelogram is the same as the height of the trapezoid, right? So we start with this as our height of our trapezoid. If we make an exact copy of it, it's still the same height all the way across, right? There's going to be the same distance from top and bottom of the parallelogram. And the length of the base of the parallelogram is the sum of the lengths of the two bases. So we have here, we can call this base 1, and we can call this base 2, right? So if you tell me what base 1 is and base 2, and we make a copy of it, this is base 1 now, down here, right? This shorter part of the trapezoid, and the longer part is base 2. So the area of a trapezoid is the sum, so add base 1 and base 2 together and multiply by the height. Okay. And so this is our area formula for trapezoid. Base 1 plus base 2 times its height. So basically, the area of a trapezoid is half the area of a parallelogram. So the area of a trapezoid is half its height multiplied by the sum of the lengths of its two bases. Okay, so take half of the height times base 1 and 2, because we only have a trapezoid. So the half comes in because a trapezoid is just half of a parallelogram. So we're going to take half the height times the sum of base 1 and base 2. So let's practice a couple. So a section of a deck is in the shape of a trapezoid. What is the area of this section of the deck? And so we say base 1 is 17. Base 2 is 39. The height is 16. So if we took this exact trapezoid, copied it, and flipped it, right, the whole base would be 39 plus 17 times the height. But we only have half of the parallelogram because we have a trapezoid. So half times 16 times the sum of 17 and 39. Well, we can take half of 16, which is 8, and multiply by 56. And we get 448 square feet. Okay. Now let's try one ourselves. So the length of one base of a trapezoid is 27 feet. And the length of the other base is 34 feet. And the height is 12 feet. Okay. So the height is 12 feet. So we're going to say area equals half the height times the sum of base 1 plus base 2. Okay, well, the height in this case is 12, so area equals 1/2 times 12 times 27 plus 34. So half of 12 is 6, and 27 plus 31 is 61. And 6 times 61 is 366 square feet. So we've talked about two so far. Parallelogram is area equals base times height. Trapezoid is going to be half the height of the trapezoid plus the sum of base 1 and base 2. All right, so now how about area of a rhombus? Well, a rhombus is a quadrilateral in which all sides are congruent. That means they're exactly the same, right? And opposite sides are parallel. Opposite sides parallel, all four sides are congruent. A rhombus can be divided into four right triangles that can then be rearranged into a rectangle. So in other words, if we draw a diagonal, two diagonals, we have four right triangles. And if we put them together, we form a triangle. We form a rectangle, right? And so the base of the rectangle, the base of this rectangle, is the same length as one of the diagonals. This line is the same as the base of the rectangle. And the height of the rectangle, B, this green line, is half the length of the other diagonal. So, again, we know that the area of parallelograms, or quadrilaterals in this case, is base times the height. Well, in this case, the base is diagonal 1 times half of diagonal 2. Does it matter which one you call diagonal 2? No. Okay, the diagonals are the same length. So it doesn't matter which one you call D1 and D2. So we come up with area equals 1/2 the product of D1 times D2. Diagonal 1 times diagonal 2. Okay, so there's our third area formula. So here in example 2, Cedric is constructing a kite in the shape of a rhombus. The spars of the kite measure 15 inches and 24 inches. How much fabric will Cedric need for the kite? All right, so we're saying D1 is 15. Okay, this diagonal is 15, and this diagonal is 24. So all we have to do is substitute the known numbers into the formula. So we have 1/2 diagonal 1 times diagonal 2. Okay, and here it doesn't, we can use the commutative property of multiplication to put 24 next to the 1/2, because half of 24 is easier than half of 15. Half of 24 is 12, so 12 times 15, that would give us 180 square inches. Okay, so you go ahead and practice. We're going to find the area of 4 different rhombuses. So again, they give us the diagonals. So always start with the general formula. For a rhombus, it's half of diagonal 1 times diagonal 2. Because remember, it was diagonal 1 times half the length of the second diagonal. But basically, it still means the same thing as if I just put the half in front. All right, so substitute 35 times 12. Okay, well, I see that half of 12 is easier than half of 35, so I'm going to rearrange that. And I'm going to have the area equals 6 times 35. That's going to give me 210 square meters. Okay, number 4. Okay, 1/2 diagonal 1 times diagonal 2. So area is 1/2 9.5 times 14. Well, I want to take half of 14 rather than taking half of 9.5. So area equals 1/2 of 14 times 9.5. So 7 times 9.5. 66.5 inches squared. All right, number 3. Oh, that was 3, sorry. 3 and 4. Number 5. Okay. We're using the same formula because we're finding the area of a rhombus. Diagonal 1 times diagonal 2. Take half of it. Half of 10 times 18. Well, I could take half of 10 and get 5. Okay, so let's do that. And then we'd have 5 times 18. Some of you might have said, well, let's take half of 18 and get 9. And 9 times 10, that's 90. So either way, so 90 square meters. All right, number 6. Area equals 1/2 diagonal 1 times diagonal 2. Substitute the known values. All right. So I really don't want to take half of this mess here, 8 1/4. So I'm going to take half of 40. So I'm going to rearrange it using the commutative property of multiplication. And I'm going to go ahead and change 8 1/4 to 8.25. Because 1/4 is a quarter, right? So this is 8 and 1/4. So 8 and 25 hundredths. Half of 40 is 20 times 8 1/4. 165 square feet. All right, number 1. Find the area of the parallelogram. Okay, and they already gave us the formula here, base times height. What's the base? 13. What's the height? 9. So we just have to multiply those together. 13 times 9 would give me 117 square inches. Okay, number 2, find the area of the trapezoid. So again, the formula for trapezoid is half the height times the sum of base 1 and base 2. So take half of the height and then add the bases. All right, well, half of 14 is 7, and 9 and 15 is 24. So 24 times 7. We get 168 centimeters squared. All right, number 3. Find the area of the rhombus. So we have 2 diagonals here, right? We know that it's diagonal 1 times half of the second diagonal. So, and as this is the formula we use, 1/2, basically the product of diagonal 1 and diagonal 2. So we're going to put in 18 and 11. I like the 18 next to the half. That's going to be 9. And I'm going to multiply by 11. That's easy. 9 times 11 is 99 inches squared. All right, number 4. How can you find the areas of parallelograms, rhombuses, and trapezoids? Well, basically, that's our formulas, right? Parallelogram, we're going to do area equals base times the height. Trapezoid, we're going to take half of the base, half of the height times the sum of base 1 and base 2. I'm going to rewrite that. All right, so I was squeezing in the H. I didn't like that, so I rewrote it. Half of the height times the sum of base 1 and base 2. And finally, a rhombus would be the area of, the area would be equal to half diagonal 1 times diagonal 2. Then we're just going to substitute the known values into those formulas. And solve the equations. Okay. So we're going to use those formulas, substitute the known values into the formulas, and solve the equations. Okay. 377. Number 5. Find the area of the parallelogram. Okay, so they didn't give us the formula, right? But we know that area of a parallelogram is base times height. In this case, the base is 14 and the height is 6. Okay, well, 14 times 6. 84 centimeters squared. Okay, again, start with the formula, substitute the known dimensions, and solve the equation. Number 6. What is the area of a parallelogram that has a base of 12 3/4 inches and a height of 2.5 inches? Okay, parallelogram. So area equals base times height. The base, I'm going to write it as 12.75. 3/4 is the same as 75 hundredths. And a height of 2.5. Because a half is 5/10. So just multiply those together. $31.875 or 31 7/8 square inches. Okay, number 7. Find the area of the trapezoid. So we know what trapezoid is 1/2 the height times the sum of base 1 and base 2. The height in this case is 24. And base 1, 42 plus 36. Well, half of 24 is 12. So 12 times 78. So 78 times 12. (936 square inches). And number 8. The bases of a trapezoid are 11 meters and 14 meters. The height is 10. What's the area of the trapezoid? Area of trapezoid, 1/2 the height times the sum of base 1 plus base 2. So area equals 1/2 times 10 times 11 plus 14. Half of 10 is 5. So 5 times 25. Well, I know 4 times 25 is 100, so 5 times 25 is 125 square meters. Number 9. Okay, find the area of the rhombus. So remember, it's diagonal 1 times half of diagonal 2. So we write area equals 1/2 the product of diagonal 1 and diagonal 2. So 1/2 16 times 9. I like the 16 next to the half because that's nice and easy to take half of. So we're left with 8 times 9. Okay, well, that's 72. So 72 square meters. All right, number 10. The diagonals of a rhombus are 21 meters and 32 meters. Okay, start with the formula. 1/2 21 times 32. Well, I don't want to take half of 21. I like to take half of 32. So I'm going to rearrange that using the commutative property of multiplication. Half of 32 is 16. So I have to multiply 21 and 16. $336 square meters. All right, let's move on to number 11. The seat of a bench is in the shape of a trapezoid. It's got bases of 6 and 5 and a height of 1.5. What's the area of the seat? Formula for area of a trapezoid: 1/2 the height times the sum of base 1 plus base 2. The height is 1.5 times base 1 and base 2, 6 plus 5. So A equals half of 1.5 times 11. Well, let's see. What's half of 1.5? Well, if I think of that as money, right? That's kind of like saying $1.50 right there, right? Half of $1.50 is 75 cents. So I'm going to say 0.75 times 11. I'm going to go ahead and write an X there so I don't get confused. Okay, that's a whole number. So 11 times 75 hundredths. Eight and 1/4, or 8 and 25 hundredths square feet. Okay. Number 12, a kite is in the shape of a rhombus, diagonals that are 12 and 15. So we're going to take half of diagonal 1 times diagonal 2. So area equals 1/2 25 times 15. I really don't like either one of those for taking half, but I'll go ahead and take half of 15. So we have area equals 7.5 times 25. Okay, how did I get 7.5? I took half of 15. 5 times 5, 25. 7 times 5 is 35. 14 plus 3 more is 17. 187.5 inches squared. Or we can say 187.5 inches squared. "13. A window in the shape of a parallelogram has a base of 36 and a height of 45. So area equals base times height. Area equals 36 times 45. Just multiply those two dimensions together. (1,620 inches squared). All right, and 14. Find the area of the figure. Explain how you found your answer. Okay, so we have two shapes here, right? Okay, we have a rectangle, right? So that could be just basically length times width. And then we have a trapezoid. And we know that that's half the height plus base 1 plus times the sum of base 1 and base 2. So the area of the rectangle is A equals 18 times 12. And so 18 times 12, 216 square feet. Find the area of the trapezoid. 1/2 times 6 times 10 plus 18. Okay, if this is 18, then the base of this is also 18. Okay, so base 1 is 10, base 2 is 18. The height of the trapezoid is 6. All right, so half of 6 is 3, and 10 and 18 is 28. 28 times 3, 84. 216 plus 84 gives me 300 square feet. Okay, I know 84 plus 16 is 100. 100 plus 200 is 300. So what did we do? We found the area of the rectangle, found the area of the trapezoid, and added them together. All right, backside. Page 378, number 15. A parking space shaped like a parallelogram has a base of 17 feet and its height is 9 feet. A car parked in the space is 16 feet long and 6 feet wide. How much of the parking space is not covered by the car? Well, we basically have two problems here. We've got to find the area of the parking spot and the area of the car. Okay, well, we can do that. They told me the parking spot is shaped like a parallelogram, so that's just base times height. And they told me the base is 17 and the height is 9. Well, 17 times 9, that's going to be 153 square feet. The car is length times its width, and the length is 16, and it's 6 feet wide. 16 times 6, 96 square feet. How much of the parking space is not covered by the car? Now we just need to subtract. 153 minus 96 will give us 57 square feet is not covered by the car. All right, 16. Simon says that to find the area of a trapezoid, you can multiply the height by the top base and the height by the bottom base, then add the two products together and divide the sum by 2. Is Simon correct? Yeah, he is. What's he using? He's using the distributive property. Okay, he's using the distributive property. And then what? To multiply each. Now in our formula, we said multiply by 1/2, but multiplying by 1/2 is the same as divide by 2. Okay. So he's using the distributive property to multiply each base by the height. So in other words, let's look at this. 1/2 the height times the base 1 plus base 2, right? So if you tell me that the height is, I don't know, something like 4, and base 1 is 6, and base 2 is 4. Well, I can take this 4 and distribute it and multiply by each of the bases. Okay. So in this case, it would be 24 plus 16. That would give me 40. Okay, so I have 1/2 times 40. But what he did was 40 divided by 2. You could do that. Okay, so he's right. All right, number 17. So the height of a trapezoid is 8 inches, and its area is 96 square inches. One base is 6 inches longer than the other base. What are the lengths of the bases? Okay, so we're still going to start with the formula for trapezoids. Okay, and we know 1/2 the height times the sum of the base 1 and base 2 gives us the area. Well, they gave me the area this time. So let's plug in what we know. We know the area is 96. We know the height is 8. And then we have to figure out what our bases are. Okay, so let's first take 1/2 of 8. Okay, so we're going to simplify our problem. So I see that 4 times, this is like a variable, right? 4 times x equals 96. So to get rid of the multiplication, we're going to divide by both sides by 4. So on the right-hand side, I'm left with base 1 plus base 2 equals 24, because 96 divided by 4 is 24. Now, I can just use some guess and checks in a sense, right? I'm looking for 2 numbers that add up to give me 24. Well, I can start with 12 and 12. Okay, I'm trying to find something where one of them is 6 inches longer than the other. Well, if I add 1 to one side and subtract the other, I still have 24. This is a difference of 2. That's not going to work. Let's go 14 and 10. That's a difference of 4. That still doesn't work. 15 and 9. Okay, that's 24, and it's a difference of 6. So 15 and 9. So okay, so the first thing we did was substitute the known values into the formula. I took 1/2 of 8 to get 4 times the sum of base 1 plus base 2 equals 96. I divided both sides by 4. That left me base 1 plus base 2 equals 24. I tried different add-ins. Until I found 2 that showed a difference of 6. 15 plus 9. So I took half of 8 to get 4. That left me with 4 times the sum of base 1 plus base 2. And that equals 96. I divided both sides by 4 to isolate base 1 plus base 2. And then I just tried different numbers, that different add-ins that added up to 24, but also had a difference of 9. Difference of 6. And that came out to be 15 and 9. All right, and now number 18. The diagonals of a rhombus are 12 inches and 16 inches. The length of a side of the rhombus is 10 inches. What is the height of the rhombus? Explain how you found your answer. Okay, so let's go look at what's the formula for a rhombus. Area equals half diagonal 1 times diagonal 2. Okay, they gave us that one of the diagonals was 12 and the other one is 16. Okay, so let's continue to solve that. Half of 12 is 6. 6 times 16, 96. Okay, so now a rhombus is a parallelogram, right? And a parallelogram has a formula of area equals base times height, right? Well, in our question, they told me the height was 10. Okay, so 10 times b equals 96. Divide both sides by 10. That'll leave me with the base. And 96 divided by 10 is 9.6. So 9.6 inches. How did I solve that? I substituted the known values. To find the area of the rhombus. A rhombus is a parallelogram. So I used the formula A equals base times height. To get the length. $96 equals 10 times b. b equals 9.6 inches. Okay. All right, so that's it for our discussion of area of quadrilaterals. In our next session, we'll talk about area of triangles. So until then, I will see you soon.